Good day, grade 7. I am going to discuss to you about irrational numbers. So our learning competency here is the learner estimates the square root of a whole number to the nearest hundredth. The learner also plots irrational numbers up to square roots on a number line. So what do you need to understand here? Okay, so what do you need to understand? In lesson 1, we have estimating square root of a whole number. So to estimate the square root of a whole number to the nearest hundredths, we must follow the following steps. So number 1, we have to determine the square root of a number that lies between two integers. Number 2, okay, so number 1, you have to determine the square root of a number that lies between two integers. Number 2, simplify the following ratio to determine an approximate fraction or decimal. So we have this formula. We have irrational number minus lower perfect square number divided by the upper perfect square number minus lower perfect square number. Number 3, by the way, perfect square numbers are like 1, 4, 9, 16, 25, 36. So those are perfect square numbers which has a factor, same factors, or which has two factors which are the same. Number 3, we have write a mixed number where the whole number is the square root of the lower perfect square and the ratio of the approximate fraction to a decimal. Example, we have here example number 1. Estimate square root of 27 to the nearest hundredths. Okay, step 1. So given the irrational number. So this is our irrational number, square root of 27. What is the lower perfect square? Okay, lower perfect square. So we have, what are those perfect square? We have 1, 4, 9, 16, 25, 36. And 27 is in between 25 and 36. And the lower is perfect square number is 25 and the upper perfect square number is 36. So 27 is in between the two perfect square numbers which are 25 and 36. So we will choose that one. We set this to be your lower perfect square and this is your upper perfect square number. What is the square root of 25? The square root of 25 is 5 and the square root of 36 is 6. Okay, that's it. So therefore, square root of 27 can be found between 5 to 6. Okay, so that's it, the approximate of the square root of 27. So number 2, irrational number minus lower perfect square. What is our irrational number? Our irrational number is 27. So this will become 27 minus the lower, which is 25, divided by the upper perfect square, which is 36 minus 25. Therefore, subtracting, we have 2 over 11. So therefore, square root of 27 is equal to 5, which is this one, and 2 over 11. And that is, that is 5 plus, okay, 2 over 11. So dividing that one, okay, so dividing that one, that is 2 divided by 11 is 0.181818 like that. So therefore, square root of 27 is 5.181818. So by rounding it off to the nearest hundredths, we get 5.18. Okay, so this one is on the step number 2. We have here step number 2. Simplify the following ratio to determine approximate fraction or decimal. So ito yon. Okay, so write the mixed number where the whole number is the square root of the lower perfect square. So, and the ratio of the approximate fraction to the decimal. So step 3 there, you just get the perfect square of the lower, the square root of the perfect square of the lower perfect square number plus the step 2. Dividing, and that is 5.18. By the way, this one is 5.18, 18, 18, and so on. Since it is asked that you should round off this to the nearest hundredths, so therefore it is on the 2 decimal places. We need 2 decimal places, and that is 5.18. Okay, that's it. Example 2. Estimate square root of 85 to the nearest hundredths. Again, step 1. Principal root of 85 is between 9 and 10 because if we're going to determine the perfect square numbers, 85 is in between 81 and 100. 81 is a perfect square, 100 is a perfect square. So therefore, 85 is in between. The square root of 81 is 9. The square root of 100 is 10. Okay, so 85 is in between the square root of 81, which is 9, and the square root of 100, which is 10. So therefore, again, irrational number 85, that is step 2. Okay. By the way, the square of 9 is... Okay, this is the one. Square of 9 is 81, the square of 10 is 100. These are the perfect square numbers. Okay, so therefore 85 is in between 81 and 100. So irrational number, step 2, minus the lower perfect square. Lower perfect square is 81. Upper perfect square is 100 minus 81. So that is subtracting, we have 4 over 19. And we will get the lower perfect square is 9. So therefore we have 9 and 9 over 14. 9 divided by 14 is 0.2105 and so on. Then round it to the nearest hundredths. So you will not add 1 because the next number is 0. So that will become, or that will just retain to 9.21. Okay, that's it. Next, example 3, we have estimate 141 to the nearest hundredths again. So the principal root of 141 is in between. By the way, 141 is in between 121 and 144 because you have 11 times 11 is 121, 12 times 12 is 144. So 141 is in between 121. This is the perfect square number, the lower perfect square number and the upper perfect square number. So 141 can be found in between these 2 perfect square numbers. Okay, and square root of 21 is 11. 121 is 11, and square root of 144 is 12. So therefore, the square root of 141 is or lies in between 11 and 12. So using the step 2, we will have the irrational number 141, which is this one, minus the lower perfect square number, which is 121, divided by the upper perfect square number 144 minus the lower perfect square number, which is 121. Subtracting, we have 20 over 23. 20 over 23 is 8.869 and so on. Getting the lower perfect square number, the square root of the lower perfect square number, which is the square root of 121 is 11 plus 20 over 23. When you divide 20 over 23, that is 0.869 and 11. Just retain the 11 here. Since we are going to round off it to the nearest hundredths, So therefore, you will add 1 because that is greater than, or this is 5 and above. So you will add 1, that will become 0.87. So therefore, the square root of 141 is 11.87. Okay. So, activity 1, you are going to estimate each square root to the nearest hundredths. So, you just do the step 2 here. Okay, so square root of 21 is in between 4 and 5. So, our lower perfect square number is, you find the lower perfect square number and the upper perfect square number. You just do like this. You get the square, and this is your lower perfect square number, and this is the upper perfect square. You just square 11. 11 times 11 is 121. 12 times 12 is 144. So that's it. So it's similar there. So you just follow the examples. Okay, just follow the examples similar to that one. Estimate each root to the nearest hundredths. So again, you will find, okay, here, you will find the 2 perfect square, okay, which 27 lies in between. So like for example, sa 27, saan ba yan? In between 2 perfect square. Ito naman, look for a 2 perfect square wherein the other one is the lower and the other one is the upper, and then you do the same steps, follow the same steps. Okay, so with the key points here, these are the things to remember, needs to remember. So we have here the square roots of irrational numbers such as square root of 2, square root of 3, and square root of 5 can be estimated or approximated to the nearest hundredths from values or integers between which the square root lies. So to estimate the square root of a whole number to the nearest hundredths, we must follow the same or the following steps. So determine the square root of a number that lies between 2 integers, then simplify the following ratio to determine the approximate fraction or decimal, which is irrational number minus the lower perfect square number divided by upper perfect square number minus the lower perfect square number. Then write the mixed number where the whole number is the square root of the lower perfect square and the ratio of the approximate fraction to a decimal. So that's it. You just follow. Okay, so just answer this by shading the letters of the correct answer here. Same here. So this here you're going to color your way to finish line, to the finish line by estimating the square root of a number to the nearest hundredths. So here you're going to find the square root of 98 and then you shade. Okay, for example, the square root of 98 is this one, so you have to shade this one. Then since the arrow is going here, so you look again for the square root of 15, which is, what is the square root of 15? Is it this one or that one? If this is the answer, then shade this one. Then this is the arrow going here, so what is the square root of 52? Is it this, or is it this one? So if this is the answer, then you just shade this one too, then answer this one. Then if it is this one or this one, so you just shade the answer. Okay, to the finish line. So that's it for today. So the same process with this one. Assessment 3, you just find out the message by estimating the square root of a number to the nearest hundredths. So find the estimated value from the box below, then write the letter of the corresponding answer. So you have the coded message here. So like number 1, what is the square root of 5? So you just look here. If your answer is 2.2, then you write the letter M in number 1. So that is letter M. That is just an example. You need to solve that one. Then, plot irrational number on a number line. So, how are you going to plot a number on a number line? A number line can be defined as a straight line with with numbers placed at equal intervals or segments along its length. It can be extended infinitely in any direction and is usually represented horizontally. The square root of a number is a value that can be multiplied by itself to give the original value. The principal square root is the positive square root of a number. So we call the positive square root of a number, we call that as the principal square root. Okay, next. Positive and negative numbers, zero and decimal numbers, can be easily represented on a number line by identifying the origin first and then moving on to the positive or negative numbers. So again, this is our number line, usually represented in a horizontal line. Then the middle one is your origin. To the left are negative numbers, to the right are positive numbers. So to the right, you start with 1, 2, 3, 4, 5, 6, and so on. Then to the left, you have negative 1, negative 2, negative 3, negative 4, and negative 5, and so on. So, irrational numbers are numbers that cannot be expressed as a fraction. So, if the number cannot be expressed as fraction, so that means that number is an irrational number. Example of these numbers are like pi. You have the value for 5, which is 3.14, 16, and so on. Then we have square root of 12, square root of 34, square root of 18, square root of 2, square root of 53, square root of 8. These are examples of irrational numbers. Next, steps in plotting irrational numbers on a number line. So identify the principal root of the given irrational number. Find the perfect square number that is near to your given irrational number. Then, to get the estimate or approximate value, plot the estimate or approximate value on a number line. So, like for example, plot pi on a number line. We want to plot pi on a number line, but most of us already know that pi is approximately equal to 3.14, 15, 6.6, and so on. And we usually round up that to hundreds, 10,000, and we usually use 3.1416. But the answer, the value really of pi is 3.14, 15, 6.6, 626 dot, and so on. So that is continuous. Then, so 3.14. So we want to plot that one. So, and that is somewhere here. 3.14. So you just approximate that one. And 0.14 is like you can divide that by 0.14 somewhere. 0.14. This is half here. So half of that, then another half of that. You just approximate. Okay. Next, locate. By the way, here, half of this is 3.5. The next half, 1/4 is 3.25. Half of 3.25 is 3.12. So 3.125, and that is somewhere here. Okay, yeah. Locate square root of 12 on the number line. How are you going to locate? So look for the principal root of 12 that is between. We will get the lower square root and the upper square root. Upper perfect square number and the lower perfect square number. So the lower perfect square number is 9 and the upper perfect square number is 16. The square root of that is 3 and the square root of 16 is 4. So therefore, square root of 12 lies in between 3 and 4. So that is 3 and 4. So in between. Negative 12 is nearer to 9, which is 3. Okay, so nearer to 9 than 16. 12 is nearer to 9 than 16. So since 12 is greater than 9, then the square root of 12 is greater than 3. somewhere here. Using calculator, you have the square root of 12 is 3.464. But you can estimate here using the process above. You just get the, okay, you use the step 2. The step 2 that is irrational number minus the lower perfect square divided by the upper perfect square minus the lower perfect square. Then you can get the decimal number there. Number 3, the same process with number 3. You get the upper or the lower perfect square number, which is 25. The upper perfect square number is 36. Okay, so upper perfect square, but 34 is nearer to 36 than 25, so which is 6. So since 34 is less than 36, then square root of 34 is less than 6. So somewhere here, nearer 6. This is just an approximate. Okay, how about here? Plot negative 18. By the way, the lower perfect square, okay, lower perfect square number is 16, and the upper is, okay, the upper should be 25. The upper should be 25. This should be 16 and 25. Okay, this must be 25. So negative square root of 18 is in between negative 4 and negative 5. It should be negative 5. Okay, then negative square root of 18 is nearer to 16 than 25, right? So therefore, which is negative 4, nearer to negative 4. So therefore, negative 18 is less than negative 16. Then negative square root of 18 is less than negative 4. Okay. The square root of, negative square root of 18 is less than negative 4. So if it's less than negative 4, somewhere there. Okay. If somewhere here this is greater than already negative 4, it should be going that way. Okay, so practice. You have the activity 1, you have to plot this one. So just find the two lower and upper perfect square number, then you just plot the approximate nearer to which perfect square number. Okay, so the same process here. Okay, draw your own number line for each of the following irrational numbers and plot their roots. Okay, you are going to draw the number line, but before that, you have to find first the upper and the lower perfect square and the upper perfect square. Then find out which is nearer, where it is nearer to, and plot the point. The same process with number 2, 3, 4, and 5. So, key points. In plotting irrational numbers on a number line, we need to be guided by the following steps. So, first, you are to identify the principal root of the given irrational number. Okay. Find the perfect square that is near to your given irrational number to get the estimate or approximate value. Then plot the estimate or approximate value on a number line. So, okay, you have here. You just answer this one by choosing the letter that corresponds to the correct answer. So that's all for today. I hope you learned something. Don't forget to subscribe my YouTube channel. Thank you so much for watching.